Here are the rarest cosmic events that could end life on Earth. Every morning, 8 billion people wake up on a blue marble spinning through the void. We brew coffee, scroll through phones, plan our futures. But here's something most of us never consider. Our planet exists in a cosmic shooting gallery, and we've just been incredibly lucky. In the 4.5 billion years Earth has existed, countless cosmic catastrophes have swept through our galaxy. Most missed us by astronomical distances. But statistically speaking, our number could come up at any moment. And when it does, there may be no warning, no time to prepare. Just the end. Today, we're exploring 5 terrifying scenarios that keep astrophysicists up at night. These aren't Hollywood fantasies. They're real threats backed by scientific evidence and mathematical probability. Let's begin with the most violent explosion in the universe. 1. A supernova radiation burst. Right now, about 600 light-years away, a star called Betelgeuse is dying. It's a red supergiant so massive that if you placed it where our sun is, it would engulf Mercury, Venus, Earth, Mars, and extend halfway to Jupiter. And it could explode at any moment. When stars more than 8 times the mass of our sun exhaust their nuclear fuel, they don't fade quietly. They detonate in a supernova, an explosion so bright it can briefly outshine an entire galaxy. The energy released in those few seconds exceeds what our sun will produce in its entire 10 billion year lifetime. But here's what should terrify you. It's not just the light show. A supernova unleashes a tsunami of high-energy radiation, X-rays, gamma rays, and cosmic rays traveling at near light speed. If a supernova occurred within 30 light-years of Earth, this radiation would strike our planet like an invisible hammer. The ozone layer, our shield against ultraviolet radiation, would be stripped away in hours. Without it, the sun's UV rays would sterilize the surface. Phytoplankton, which produce 70% of our oxygen, would die en masse. DNA would shatter under the radiation onslaught. Skin cancer rates would skyrocket. Crops would fail. The food chain would collapse from the bottom up. Scientists believe a nearby supernova may have caused the Ordovician extinction 450 million years ago, which wiped out 85% of marine species. The evidence? Isotope signatures in ancient rock layers that suggest a gamma-ray bombardment. The good news? There are no supernova candidates close enough to threaten us right now. Betelgeuse is too far. But in our galaxy's 200 billion star population, statistics are not on our side forever. And here's the truly unsettling part. By the time we see a supernova happen, it's already too late. The lethal radiation travels at the speed of light. We'd be dead before we knew what hit us. 2. Gamma-ray bursts. If a supernova is a shotgun blast, then a gamma-ray burst is a cosmic sniper rifle, and it's aimed directly at you. Gamma-ray bursts, or GRBS, are the most energetic events in the universe since the Big Bang. They occur when massive stars collapse into black holes or when neutron stars collide. In just a few seconds, a gamma-ray burst releases more energy than our sun will produce in its entire existence. But unlike a supernova, which radiates in all directions, a GRB focuses its energy into narrow jets traveling at 99.99% the speed of light. Think of it as the universe's lightsaber, a death beam slicing through space. And if Earth happens to be in the crosshairs when one goes off, even from thousands of light years away, we're finished. The gamma rays would hit our atmosphere with the force of 1 billion nuclear bombs. Within seconds, chemical reactions in the upper atmosphere would generate massive quantities of nitrogen dioxide, turning the sky brown. The ozone layer, again our only shield, would be obliterated in minutes. But it gets worse. The nitrogen dioxide would trigger a rapid ice age by reflecting sunlight back into space. Global temperatures would plummet. Agriculture would become impossible. And while the planet froze, any organism exposed to the surface would be cooked by UV radiation during daylight hours. Scientists theorize that a gamma-ray burst may have triggered the late Ordovician extinction. The same event possibly linked to a supernova. The 1-2 punch. Radiation sterilization followed by global freezing. 85% of species gone. We detect gamma-ray bursts almost daily in distant galaxies. Cosmic graveyards where we witness worlds ending in real time. On average, one occurs in our Milky Way galaxy every few 100,000 years. But here's the nightmare. We can't predict where the next one will aim its jets. We have no warning system, no defense. All we can do is hope that in the cosmic lottery, our number doesn't come up. Because if a gamma-ray burst within a few thousand light-years points at Earth, our species wouldn't just go extinct. We'd be erased so quickly that the last generation might not even realize what was happening. 3. An asteroid or comet impact. 65 million years ago, the dinosaurs ruled Earth. They had dominated for 165 million years, longer than mammals have existed. They survived ice ages, volcanic eruptions, and climate shifts. They seemed invincible. Then, on an ordinary day, the sky caught fire. An asteroid roughly the size of Mount Everest, traveling at 20 kilometers per second, slammed into what is now the Yucatan Peninsula. The impact released energy equivalent to 10 billion Hiroshima bombs. Instantly. The asteroid vaporized on contact, creating a crater 180 kilometers wide and 20 kilometers deep. The shockwave flattened everything within 1,500 kilometers. Mega tsunamis hundreds of meters tall raced across oceans. Earthquakes exceeding magnitude 10 shattered the crust. But none of that killed the dinosaurs. What killed them was the aftermath. Trillions of tons of vaporized rock and debris were blasted into the atmosphere. As this material fell back to Earth, friction with the air heated it until it glowed, essentially turning the entire sky into a broiler oven. Global wildfires ignited simultaneously across every continent. Then came the darkness. Soot and ash blocked out the sun for years, plunging Earth into an impact winter. Temperatures dropped below freezing, photosynthesis stopped. Plants died. Herbivores starved. Carnivores followed. 75% of all species went extinct. But here's what should concern us. This wasn't a rare event. Earth has been hit by civilization-ending asteroids multiple times. And right now, thousands of near-Earth objects cross our planet's orbital path. NASA has cataloged about 30,000 near-Earth asteroids, but estimates suggest there may be over 1 million larger than 40 meters, big enough to destroy a city. In 2013, a 20-meter asteroid exploded over Chelyabinsk, Russia, with the force of 30 Hiroshima bombs. It injured 1,500 people. We never saw it coming. And then there are long-period comets, frozen time bombs that spend centuries in the outer solar system before plunging toward the sun. By the time we detect them, we might have weeks of warning, maybe days. The dinosaurs had no space program, no planetary defense system. But we do. NASA's DART mission successfully altered an asteroid's orbit in 2022, proving that deflection is possible if we have enough warning time. The question isn't if another major impact will happen. It's when and whether we'll be ready. Because unlike the dinosaurs, we have the technology to see it coming. We just need to look. 4. The death of the sun. For 4.5 billion years, the sun has been our loyal companion. Constant, reliable, life-giving. We've built our entire civilization around the assumption that it will always be there. But it won't. Right now, the sun is slowly getting hotter. Every 100 million years, it brightens by about 1%. That might not sound like much, but it's a death sentence for complex life on Earth. And it's already underway. In about 1 billion years, increased solar radiation will accelerate the water cycle. More ocean water will evaporate. Water vapor is a greenhouse gas, so this will trap more heat, causing more evaporation. A runaway greenhouse effect. Earth will transform into a second Venus. The oceans will boil away completely. Without water, plate tectonics will cease. The carbon cycle will stop. Temperatures will soar to over 100 degrees Celsius. Any remaining life will retreat to underground pockets, then vanish entirely. Earth will become a scorched, lifeless rock, still in the habitable zone, but utterly uninhabitable. But the sun isn't done. In about 5 billion years, it will exhaust the hydrogen fuel in its core. With no outward pressure from fusion to balance gravity, the core will contract and heat up. Hydrogen in the surrounding shell will ignite, causing the outer layers to expand dramatically. The sun will become a red giant, a bloated, dying star, hundreds of times its current size. It will swallow Mercury, then Venus. Earth may technically survive on the outer edge of the expanding envelope, but survive is generous. Our planet will be a cinder, stripped of its atmosphere, tidally locked, with one face melting under the red giant's gaze. Eventually, the sun will shed its outer layers in spectacular planetary nebulae, exposing its white dwarf core, a dense, Earth-sized ember that will slowly cool over trillions of years. This is the inevitable fate of all solar-type stars. There's no escaping it. No technology can stop it. The only question is, will humanity still exist in a billion years? And if so, will we have learned to leave our solar system behind? The death of the sun is the most certain cosmic catastrophe on this list. We know it's coming. We know when. We just don't know if we'll be around to witness it, or if we'll have become something far greater, spreading across the stars while our home sun collapses into its final sleep. 5. Rogue planets and black holes. Imagine playing billiards on a table the size of a galaxy. Now imagine someone shoots a cue ball through your game at 100,000 kilometers per hour. That's essentially what a rogue planet or black hole encounter would be. A cosmic intruder smashing through our carefully balanced solar system. Rogue planets are worlds without stars, ejected from their birth systems through gravitational interactions or catastrophic events. They drift through the void and darkness, frozen wastelands with temperatures barely above absolute zero. And our galaxy may contain billions of them. If a rogue planet passed through our solar system, it wouldn't need to hit Earth to destroy us. Its gravitational pull would disturb the orbits of everything nearby. Jupiter might be nudged inward, destabilizing the inner planets. The asteroid belt could be scattered. Earth's orbit could become more elliptical, drastically changing our climate or even ejecting us into interstellar space. Imagine seasons lasting decades as Earth swings wildly between freezing winters and boiling summers. Agriculture would collapse. Ocean currents would fail. The climate would become unrecognizable. And if Earth were flung out of the habitable zone entirely, or worse, ejected from the solar system, we'd freeze to death within weeks. But there's something even more terrifying. Stellar mass black holes. Black holes aren't cosmic vacuum cleaners. They don't suck things in from vast distances. Their gravitational pull follows the same rules as any massive object. But if a stellar mass black hole, say 10 times the mass of the sun, passed through our solar system, the effects would be catastrophic. Planets would be flung out of orbit like marbles. The sun itself might be disturbed, affecting its fusion processes, and if the black hole passed close to Earth, within the orbit of the moon, tidal forces would literally tear our planet apart, stretching it like taffy before consuming the debris. But here's the truly unsettling part. We might not see it coming. Stellar mass black holes are small, only about 20 kilometers across and emit no light. They're invisible until they're already interacting with nearby matter. By the time we detected gravitational anomalies in the outer solar system, it might be too late to do anything but watch. The probability of either event is extraordinarily low, perhaps once every few trillion years for our specific solar system. But in a galaxy with hundreds of billions of stars and even more rogue planets and black holes drifting through the darkness, probability is just a waiting game. So why tell you all this? Why confront these cosmic horrors we can't control? Because awareness is the first step toward preparation. 100 years ago, we couldn't detect asteroids or track near-Earth objects. Now we can, and we're developing technologies to deflect them. We've sent probes to the edge of the solar system and beyond, extending our senses into the cosmos. We're learning to read the warning signs. We're becoming a spacefaring species, and perhaps most importantly, we're recognizing that Earth, while precious, may not be humanity's final home. Carl Sagan once described Earth as a pale blue dot, a tiny stage in a vast cosmic arena. He was right, but that dot has produced something the universe has never seen before, a species capable of understanding its own cosmic fragility and ambitious enough to do something about it. The cosmic events we've explored today, supernovas, gamma-ray bursts, asteroid impacts, the death of the sun, and rogue cosmic intruders, are all real threats. But they're also reminders of something profound. Our existence is a temporary gift in an indifferent universe. What we do with that gift, whether we remain confined to one fragile world or spread across the stars, will determine whether humanity is just another extinct species in the fossil record or the first to escape the cosmic shooting gallery alive. The universe may not care about us, but we care about the universe. And that might just make all the difference. If you would like, come with us on this regular journey of exploring the rare, the common, and the abundant in our universe, hit the like button on this video and then go ahead and subscribe to our channel. The extremes of reality where we keep on exploring.